When we speak to clients who are building voice-enabled platforms for young children, we find that generally they need something that goes beyond a straightforward transcription of the file. The use case might, for example, be literacy, where they display a word or sentence for a child to read, and they want to return a pronunciation score to the teacher. In other cases, they want to search within a child's response for a keyword or phrase that will trigger an action, by an animated character, for example, or by a particular dialogue branch of a conversational agent or chatbot. Our software does all of this with high accuracy for speech by children as young as 3 years old and returns confidence scores right down to the individual phonemes or speech sounds that make up each word. Let me show you an example.
The horse ran fast.
With verification, the client uploads the audio as well as the text that they are interested in verifying. In this case, the child was asked to read "the horse runs fast" and instead said "the horse run fast." You can see the Z sound in run scored low because the child under-articulated that part of the word. We can see that this one mistake doesn't affect the utterance score too much, but if we break it down by word or phoneme, we can easily see the exact speech sounds where the child deviated even slightly from the script. Then we return an utterance score, and we can break it down to the word and the phoneme level. So for each word, we return a score, and for each phoneme, we return a score as well. This is clear as well in the next example, which contains a word that's slightly outside the child's reading level.
This is a racket.
You can see that the child made a good attempt at the sentence, but omitted one of the words and slightly mispronounced the end of the word. This is accurately picked up by our system. Here we can see that the child actually didn't say the word "an," and therefore our system picked up on the fact that it wasn't said in the audio file. The accuracy is something to note. You can give a good impression of accuracy by letting everything pass with flying colours, but that won't be beneficial for anyone who actually wants accurate feedback on what was spoken. Setting the bar too low leads to too many false positives, which are situations where you report that a child was correct when they didn't actually pronounce something as clearly as they could have. On the other hand, setting the bar too high, you may penalise attempts that were actually correct. SoapBox system is capable of clearly and accurately discriminating between correct and incorrect attempts, and in fact the results returned by our system agree with the results of human annotators who are linguists and teachers 95% of the time. Verification works really well for multiple choice questions and command and control. In gaming, robotics, immersive conversational play, for example. In any audio file, in a single request, we can search for 50 to 100 words or phrases simultaneously. So say you wanted to ask a child what their favorite animal was, and you'd built out a conversational response for dog, horse, monkey, dinosaur, and robot. Dog, horse, robot, dinosaur. And the child, in fact, says
chicken.
We can search for all of these targets simultaneously, and you can see here that all of them return 0, except for chicken, which returned 100%. These data points can be fed back to the developer, who then triggers an action based on this information. Verification can also be used in scenarios where the child might have an open-ended response. In these situations, the client may only be interested in certain parts of the response. Take, for example, a comprehension test. The child has been asked to read a passage about a dog, and we want to check how much they understood by asking them to describe the dog. Many answers are acceptable, but we're just interested in whether they hit on the key points. Let us simultaneously search for black, white, red, and let's put in a phrase as well. Black spots. And the child says,
the dog has black spots.
We can see that we returned 100% for black, very low scores for white and red, and black spots again came back 100%, and the full phrase, the dog has black spots, came back very highly scoring as well. This again shows how powerful the SoapBox Labs engine is. Its accuracy allows it to add real benefit to edtech, gaming, robotics platforms, and any other platforms where it's essential to accurately decipher child speech. We can see that we scored highly for the full phrases and the segments of the phrases, but badly for the words that weren't present in the audio file. This again shows how powerful the SoapBox engine is. Its accuracy allows it to add real benefit to edtech, to gaming, robotics platforms, and any other platforms where it's essential to accurately decipher child speech.